Hey everyone, this is Mr. Anderson. We're going to take a moment here to review the Chapter 4B assessment review. We'll check out all the solutions. We'll try to show all of our work and try to clear up any areas where we might need clearing up. Chapter 4B, remember, is all about solving quadratic equations, and the focus here is on quadratic equations that can't be solved using factoring. So we'll start with problem number 1 here, and I want to stress that as we get going, all of these problems can be solved using the quadratic formula, and that's why that formula is given to you here. It'll be on the assessment as well, but this particular problem, problem number 1 and 2, can be solved using the square root method, and that specifically has to do with no b term being present. There's not a linear x term. So I'll start this one by adding 42 to both sides. And if you're not sure what I mean by saying, hey, there's no linear x term, see me about that. Those two things cancel. I get 3x squared equals 546 plus 42. Just take a moment to do the math here. That works out to be 588. And then we'll continue or further isolate x by dividing both sides by 3. I get x squared then equals 588 divided by 3. That works out to be 196. Stopping here would be a problem because I've one more step, and that's to take the square root of both sides. And if I do that, 196 is a perfect square. So I get x equals 14. But delivering that as a solution isn't providing the full picture. Remember, due to the way that squares and square roots work out, there are going to be two solutions because both 14 and negative 14 squared are 196. So we do need to have that plus or minus there. My answer is not the square root of 14. My answer is x equals plus or minus 14, and then I can move on to the next one. Remember, one of the advantages to having a video here is you can stop anytime you need to. You can pause the video. Don't hesitate to do that. I'll start this one the same way. There's no b term as well in number 2, so I'll subtract 30 from both sides. I get 4x squared equals 10 take away 30 is negative 20. Now I'll divide both sides by 4. I'm going to run into a bit of a different situation here. Negative 20 divided by 4 is negative 5. If I go to try to type this one into my calculator is not going to love it. And I'll explain here that, or I'll remind you that the reason the calculator is not going to love it is due to that negative. It's going to tell you, hey, you got an error, or something to that effect. And that's not because you did anything wrong. It's just because you can't take the square root of a negative, right? So we got to do this. We got to say x squared equals. We got to factor this negative 5 into the square root of negative 1 and the square root of positive 5. Remember that now we can take the square root of this side. I apologize. I got to back up here. That may be. Oops. I got to do some erasing. Where's my eraser? There it is. That may be a bit confusing the way I described that. Let me see if I can do that again. I'm going to factor negative 5 into two factors. Sorry about that. I'm going to factor in negative 1 and then positive 5. And the reason I'm doing that is so now when I take the square root, I get things that work out, fairly nicely. The square root of x squared is, of course, x, and that's going to be equal to plus or minus, for the same reason we had the plus or minus in the last one. Square root of negative 1 is I, and then we can leave that 5 under the radical like that. So it's x equals plus or minus I root 5. Alternatively, some people will write this as x equals, they'll want to type in the square root of 5 into their calculator, so they'll say plus or minus 2.2 I. And if you want to do it like that, you can. I don't have a problem with that. Okay, jumping into number 3 down here. Number 3 looks like this. It does have a b term. So one more time, I'm specifically identifying the fact that we do have an x, not an x squared, in this problem. So I like to then go ahead and identify a, b, and c as part of my process, and that's just going to help me set up a good quadratic formula. So a equals 2, b equals negative 6, and c equals negative 9. And doing that now allows me to set this quadratic formula up, x equals negative b, so that's going to be a negative 6. Some of you guys simplify that ahead of time. Plus or minus square root of, and I put this in parentheses so we don't get duped by our calculator, negative 6 squared minus 4 times a, which is 2, times c, which is negative 9, all divided by 2a, which is 2 times 2. This next step is really for simplification purposes only. Simplify the negative b if you can. In this case I can. Negative 6 turns out to be positive 6. Then I do the plus or minus. I'll draw my division bar there because 2 times 2 I can simplify. That's 4. That other thing is called the discriminant. I like to simplify everything under the discriminant, meaning I'll go ahead and type that whole thing into my calculator exactly the way I see it, right? So I'm going to go grab my calculator and I'm typing that whole thing in there. And when I do so, I get 108. Now that's a nice positive number. It means I can go ahead and I can take the square root of 108. And when I do so, I get x equals 6 plus or minus square root of 108 works out to be 10.4 on my calculator. All right, and then all divided by 4. If you want to see the reduced radical version of the answer, you can definitely check out the review key that I've posted on Schoology. That's there. It's got the fully worked out reduced radical version, but I'm going to go proceed with the decimal here. Two possible solutions then. One is going to be 6 plus 10.4 divided by 4. The other is going to be 6 minus 10.4 divided by 4. Do the operation in the numerator first. Okay, so right here this is going to work out to be 16.4 divided by 4, which works out to be 4.1. One solution. This works out to be negative 4.4 divided by 4, and that, of course, if you do that math, works out to be negative 1.1, the other solution. Okay? I want to reiterate here that when I took the square root, I did not end up taking the square root of a negative, so no need to worry about imaginaries on that problem. Number four, here we go. I'll do this one in green. Maybe it'll stand out then a little bit from the prior example. Let's identify that we do have a b term in this problem. So there's b, good old negative 10. And the reason I do that is because that tells me the quadratic formula is going to work out nicely here. A is 1, b is negative 10, and c is 34. Remember, it's totally worth your time to identify those a's, b's, and c's, simply because if you start with bad information, I don't care how good of a math student you are, starting with the wrong inputs is going to yield incorrect output. So let's set up that quadratic formula. X equals negative b, negative 10, plus or minus the square root of b squared, which is negative 10 squared, minus 4, times a, which is 1, times c, which is 34. Let's continue that radical for a little bit there. Divided by 2a, which is 2 times 1. All right, now that we got everything set up, I'm just going to do that simplification again. So x equals negative 10 is a positive 10, plus or minus. All right, I'll do the stuff in the denominator. 2, right? 2 times 1 is 2. Now let's go ahead and calculate that discriminant. And one more time, I'm talking about everything right here. If you type that into your calculator, and pause the video if you need here, but type that into your calculator, you're going to find that that works out to be negative 36. Now this should give me a little bit of an opportunity to stop and think. And the reason I say that is because the item under the radical is a negative. That's going to yield an imaginary solution. So I should, at this point, consider factoring that into the square root of 36 and the square root of negative 1. All right? 36 is a nice perfect square. The square root of negative 1 is a, well, technically it's not a perfect square, but we do have a substitute for it, and that works out to be I, and of course the square root of 36 is 1. I'm sorry, the square root of 36 is 6, and when I simplify this, I get 10 plus or minus, square root of 36 is 6, square root of negative 1 is I, 10 plus or minus 6i over 2. Now, I bet that your math teacher is going to let you leave your answer like that. However, if you were on the ACT or the MCA or checking out a solution online, you'd probably find this simplified, because 10 can be set up over 2, and 6i can be set up over 2, and both of those things are reducible. And the way we would write that, notice I still have my plus or minus symbol there, the way we would write that is 5 plus or minus 3i. We get a complex number solution for this problem. But like I said, I bet that your math teacher would let you leave your answer like that, okay? So there's our setups, numbers 1, 2, 3, and 4. Okay, let's move on here then to number 5. And in number 5, we get an area problem, and that area problem is through the lens of a triangle. And we got to set up an equation here. We got the area given 60 square feet, and our formula for the area of a triangle is 1/2 base times height. So I'm just going to go ahead here, and I'm going to say, hey, 1/2 times my base. The base of that triangle I'm going to call x plus 5, and the height of that triangle I'm going to call x, and then I'll set that equal to my area, which is 60 square feet. All right, I'll zoom in so we can work on this, and I'm going to ask you to recall a couple things about algebra, and those couple things are going to be, if I want that 1/2 gone from this side, I'll get rid of it by multiplying both sides by 2, right? Because multiplying by 1/2 and multiplying by 2, those things cancel. And then we end up with, I'll rewrite this, x times x plus 5 equals 60 times 2 is 120. Now I rewrote this with the x out front. That way I'm more inclined to see the opportunity to distribute. X times x gives me x squared, x times 5 gives me 5x, and that's equal to 120. All right, I'm going to have an A, I'm going to have a B, and in a second I'll have a C here in standard form. And when I go ahead and solve this thing for x, I've got to do it when this thing's in standard form equal to 0. So I'm going to rewrite this like that, and I'm going to ask you to remember how we take this 120 and move it over to the other side. We're allowed to switch the side if you switch the sign of that term. Okay, so that's x squared plus 5x minus 120. If you don't like that, just go ahead and subtract 120 from both sides. But doing this allows me to say, hey, A is 1, B is 5, and C is negative 120. Now, once again, I'm set up to use the quadratic formula. So I'm going to go ahead and do that. All right, quadratic formula is going to work out really well here. I'll do it in green so it stands out. X equals negative b, negative 5, plus or minus the square root of b squared, 5 squared. I'm not too worried about putting that in parentheses because I won't be dealing with a situation where my calculator could fib to me. So let's see, b squared minus 4 times a, which is 1, times c, which is negative 120, all divided by 2a, or 2 times 1. If you need to pause here and do a little working out, you definitely can. But I think the math after those numbers 3 and 4, I think the math is going to be pretty manageable for most of us. Let's slide over here to the right, and I'll say x equals then, that's still going to be a negative b, negative 5, plus or minus. I'll rewrite that radical, and I'll simplify the denominator. 2 times 1 works out to be 2. Now I'm going to grab my calculator here and type in 5 squared minus 4 times 1 times negative 20, negative 120, I'm sorry. And when I do so, I get the value 505. All right. Now at this point, I'm going to go ahead and simplify that negative 505, or that square root of 505, because I know that that's not a perfect square. All right. Check it out. I'm going to type in square root of 505 in my calculator. Let me get that 2 down there first. Square root of 505 in my calculator. When I do that, I get 22.5. All right, so that's what that one looks like. But this is going to, of course, provide me with 2 solutions. One of them is going to be a nice positive solution. The other one's going to be a negative solution. And I'm going to do some thinking here. The negative solution is not going to be sensible for me. So that means I'm only going to consider the solution where x is going to be positive. And that happens when I add 22.5 in that numerator. All right, I'm not worried about the minus part here because I can't have a negative distance here, a negative length for one of those sides. So negative 5 plus 22.5, that works out to be 17.5 over 2. And when I do that math, 17.5 divided by 2 works out to be 8.75. All right. That means that this side right here is, this side, excuse me, right here is 8.75. This side over here is 8.75 plus 5. I think that'd be 13.75, right? And that's in case you were asked to find the dimensions. Okay, so there's the front side. I'm going to move on to the back side here. If you need, go ahead and pause this video and check the front side out again. But I'll zoom out and show you what we did here. Okay, there's our entire front side. All right, on to the back side. Second page of the 4B review. Okay, we're going to zoom in. We're going to make sure we read and understand this number 6. While marching, a drum major tosses a baton, and that baton goes up in the air. The drum major catches it at a height h feet after t seconds, and it can be modeled by that equation: h equals negative 16t squared plus 32t plus 5. The drum major catches it when it's 4 feet above the ground. Find the number of seconds that it was in the air. This, if you were in my class, is the launched object model that I promised I would give you guys. You don't need to worry about this thing being being memorized. So just remember that we can find that thing on the assessment. But I'm going to go ahead and I'm going to take that launched object model and I'm going to plug in the known information, right? Because there's only one piece of known information. I'll show you that here. Let's see. Let me just recopy it. All right, that h, that initial h right there, that's all by itself on the left-hand side of the equation. That h right there is the end height of my launched object. And in this case, we're told the drum major catches it when it's 4 feet above the ground. So I'm going to set that equation equal to 4. All right? And then just like before, I will get this thing equal to 0, and I will identify A, B, and C, use that quadratic formula. So here I go. I'll subtract 4 from both sides, do this. Those two things cancel, I get 0, negative 16t squared plus 32t. Okay, notice how I stacked the 5 and the negative 4, just identifying that those are like terms. They can be combined to make 1. Some of you guys aren't going to like that because the 0 is on the left-hand side, excuse me. If you want, just go ahead and move that over there. It doesn't matter. We're allowed to do that in an equation, right? Okay, so A is negative 16, B 32, and C is 1. All right, every once in a while it's worth checking in a quadratic formula to see if you can, or in a quadratic equation, see if you can reduce the size of your numbers. Maybe here I could have divided by, 2, 4, 8, 16, something like that, but C was 1, so that told me that that wasn't an option. All right, but I'll go ahead and I'll start with that quadratic formula setup. X equals negative b, it's negative 32, plus or minus the square root of b squared, 32 squared, minus 4 times a, which is negative 16, times c, which is 1, divided by 2 times negative 16. Okay? Now time to do a little simplifying. Nothing to simplify for that negative b. That's just going to be negative 32. We'll leave that as plus or minus. 2 times negative 16 is negative 32. Okay. Time to simplify that radical. All right. This radical's still going to be in place, but when I type in 32 squared minus 4 times negative 16 times 1, I get 1,088. All right, now if you're ahead of me here, you've taken the square root of 1,088. It doesn't work out perfectly to be a nice perfect square, but it works out pretty nice. All right, and that's because when we round to the nearest tenth, we kind of do get a whole number. All right, let me show you what I mean here. I'm going to just slide over here to the right. All right, the x equals negative 32 doesn't change, plus or minus, right? The negative 32 is on the bottom as well, right? Because 2 times negative 16 was that negative 32. When I take the square root of that 1088, I get 33.0 yada yada yada, which is effectively 33. And I'll just put in the 0.0 so it's clear that I rounded. All right, now I can go ahead and do the break apart. All right, and here's kind of what I did on the last problem as well. All right, I'll show you here. Negative 32 plus 33 over negative 32. Or, I have another solution as well, right, the minus part. X equals negative 32 minus 33 over negative 32. Now check this out. This answer right here, I'm going to have a negative number that's smaller than a positive number I'm adding to it divided by a negative. My answer over there is going to work out to be negative. I'm going to terminate this line of thinking right now. Okay, I'm just going to stop that. I'm going to go over here. Negative 32 minus 33 works out to be negative 65. I'll divide that by negative 32, and that is going to give me a positive number. This tells me when I do this math, x is about 2.03 seconds. So that means that drum major is walking along, he or she throws that baton in the air, and at that 4-foot mark, catches it. Okay, that amount of time from throw to catch worked out to be about 2.03 seconds. All right, so that's exactly what our answer means. All right, one problem left on this review, and there are the next one. It's got a nice diagram that's got a good setup for us, and we're going to go ahead and attack this problem. But I want to make sure we understand first. So let's go ahead and read it. Park is going to add a fenced area for dogs to play. Okay. One side of the fence is going to use an existing fence. So you can see the existing park fence. They're just going to build onto that with that dashed line there, and that'll be the dog play area. The other three sides are going to be built using a total of 170 feet of fencing. And the goal is to make that dog play area 3,500 square feet. Okay, so part 7I there says, hey, go ahead and write an equation to find the width of the dog play area. So essentially what they're asking me to do there is solve for x. All right, we're going to rely on a little bit of info from geometry, and that info that we have is the area formula for a rectangle, and that's just length times width. Okay, if you're working on the assessment and you need something like that and you forget it, come see me and I'll help you with that. But the setup, the length, is going to be my 170 minus 2x. My width is going to be x, and I'm given in the problem that when I multiply those, my goal should be to get 3,500 square feet. All right, so let's do some distributing here. 170 times x is 170x. X times negative 2x is negative 2x squared. That's going to be my 3,500. And then, my dears, let's go ahead and get x all by, let's go ahead and get 0 on the right-hand side so we can get x all by itself. And I'm just going to do some rewriting. I'll put that negative 2x squared out front. The 170 is positive, so that's going to be plus 170x. That 35 moves from right to left. Sorry about the bell. There's going to be a couple of them here before school. That 3,500 moves from right to left, so that's going to be negative 3,500 on the left-hand side. This, then, is an equation that can be reduced, just to make the math a little bit easier. I'm going to go ahead and divide everything by negative 2. And even though it doesn't matter, because it doesn't change it, I'm even going to do it to that 0 as well. So it's going to be then x squared. This works out to be minus 85, right? 170 divided by negative 2 is minus 85x. And then 3,500 divided by negative 2 is 1,750, and that's equal to 0. All right, so there's that. Now I can get after A, B, and C. A is going to be 1, B is going to be negative 85, and C is going to be 1,750. All right? So, ladies and gentlemen, this is going to help me solve, which is part double I. That's right below there. But when they say write and solve an equation, well, I guess I could do the solving as part A or part I here. But this is what I'm going to get credit for. This right here. Well, and technically, I guess this would also be credit worthy as well, in my opinion. But we're going to go ahead and solve for x in the diagram, and we'll do so using that quadratic formula. So I've got a, b, and c already identified. Let's start plugging things in. X equals negative b, which is a negative 85, plus or minus the square root of b squared, that's negative 85 squared, minus 4 times a, which is 1, times c, which is 1,750 or 1750 divided by 2a, which is 2 times 1. All right, so there's that. X equals, let's do the simplification. Negative 85 is a positive 85, plus or minus. On the bottom, 2 times 1 is just 2. All right, time to simplify that discriminant here. And that discriminant, when I go ahead to simplify it, works out to be the square root of 225. All right? So, what's 225 when I go to take it? Oh, geez, that's a perfect square. This one works out wonderfully. X equals 85 plus or minus. Square root of 225 is 15 divided by 2. Okay, now this one yields two possible solutions, and they're both going to be good looking initially. Let's check it out. All right, so we've got two options here. We've got 85 plus 15 divided by 2. And then we've got 85 minus 15 divided by 2. So 85 plus 15 works out to be 100 divided by 2. And we got 85 minus 15 works out to be 70 divided by 2. And 85 plus 15 divided by 2, 100 divided by 2, that's 50, right? It's a nice positive answer, right? And 70 divided by 2 is 35. Another nice positive answer. So what do we do? Well, we can plug both of these things in, and if I do so, I'm going to try to make it so we can see the diagram as well here. Give me just 1 second. If I do so, I get, for this possible solution, I get a diagram, right? Because it's a three-sided thing. This works out to be 50. This works out to be 50, and then 170 minus 2 times 50, this works out to be 70, right? So I have, in this particular case, 170 feet of fencing being utilized, all right? But if I go ahead down here, watch this. This works out to be 35. This works out to be 35. And then 170 minus, 170 minus 2 times 35 works out to be 100. Okay, so both of these things add up to, sorry about that last bell there, both of these things add up to 170, and they both give me an area of 3,500 feet. The problem is, and I'm trying to make it so you can see it here, the problem is, if I do so, this dimension right here of 100 works out to be longer than the existing park fence of 90. And you can clearly see in the diagram that I do not have a situation where I have something longer than the existing park fence, because I'm required to use that existing park fence to make this happen. So I can't go 10 feet longer. I would say that invalidates this particular answer option. I would say the x value that I need is 50, meaning that I have a, let me redraw that rectangle. I have a dimension in my diagram of 50 and 70. All right? Ladies and gentlemen, feel free to pause and rewatch, ask questions, ask anything you need. If there's something that's unclear, remember, you're in charge, okay? So go ahead and ask questions and seek answers. Thank you for your time. Thank you for watching, and we'll see you on test day. Like I said, don't hesitate to ask if you need clarification. Have a good one.